Welcome, students. Hope each one of you is fine and doing well. During our previous classes, we have studied about types of motions, and then we have discussed about friction in this chapter, and we have studied about momentum, law of conservation of momentum, and with the help of formula, we have discussed in detail. Now, today's our topic is concerned with the uniform circular motion and centripetal force, centripetal and centrifugal force. So these are two types of the forces which are linked with the bodies which are moving inside a circular path. So we will discuss in detail with examples and with the help of some figures. We will also include some of the examples from our daily life. There are thousands of examples which are linked either it's washing machine, either it's spinner, it's any other type of the machine which is the most applications are you people have seen in your houses as well. But there are a number of other examples in the universe. The universe have special types of link with these types of the motions and the force. So let's start with the uniform circular motion. So here it is the circular motion, the motion of an object in a circular path. You look at galaxy system and other types of the planets. This is one of the example, and the motion of the electron around the nucleus is also another types of the example. These are the natural types of the constructions where circular motion is there and it's going on each and every second of our life. So, what are the example? Motion of an electron around the nucleus. This is the example of a circular path. A turn taken by a cyclist while moving along the circular path. So, what's uniform circular motion? The motion of an object in a circle with uniform speed in uniform circular motion. Its speed remains same, but its velocity changes due to the change in its direction at every point. So before we go to the next point, let's revise another concept. That is, there are two possibilities of producing acceleration in a body. One is that if the magnitude of velocity is increasing or decreasing, either body starts from rest and starts moving, or if a body is moving with a certain velocity and a person applies a brake. So if a car is moving with certain velocity and a person applies a brake, then the velocity decreases from maximum to minimum value. When a car is at rest, it suddenly starts moving. Its initial velocity was zero, and then it increases. These, this is one case where acceleration is produced. But what about the other chance of producing acceleration? Whenever a body is moving inside a circular path, its speed is uniform, but its velocity is not uniform. Its velocity is changing at any after every point of a circle. So at the time when the velocity changes, of course, its direction changes. And with the change of the direction, acceleration is there. And in case of circular motion, that type of the acceleration is called centripetal acceleration. Now, what are the examples? Examples are the bucket of water when filled, its water does not fall. This is an example, and it is also as in the scientific reason sometimes why the water does not fall. The death well motorcyclist does not fall while moving on vertical wall. So moving to the next, these are the types of the forces. Centripetal force, the force which compels a body to move in a circular path. It is denoted by FC, C for centripetal force and F for force. So a type of force which is center loving means which tends to move the object inside a circular path. That type of the force is called centripetal force. And when you are studying charges and the electrons, nucleus, you will come to know that the nucleus is basically applying a force on the electron, and this force is type of centripetal force which tends to move the electron inside a circular path around the nucleus. Same is the force, gravitational force, which results into producing a centripetal force due to which the bodies are moving in a circular path. So let's see the explanation. Consider a body tied at one end of a string, moving with uniform speed in circular path. You tie stone or any other during child or younger age. Most of you must have experienced it by while tying one object with a string and moving inside a circular path and enjoying at that time that stage of your life. So this is another example of a centripetal force which you are applying with the help of string on the stone. The body tries to move in a straight line due to inertia, but hand holding the string pulls the body inside the circle and keeps it moving in a circular path. So, which element, which factor is involved to move that stone to move inside a circular path? Of course, your hand is connected with the string and a string is connected with the stone. So in between you and stone there is a string, and this string is basically responsible to produce centripetal force. The inward pull is the centripetal force, the force which is trying to move the body inside a circular path. Or center loving force is basically called centripetal force, and there are thousands of examples in our life which are directly connected with the centripetal force. In simplest way, we can say that the type of the force which is responsible to move the body inside a center is called centripetal force. But a force at the same time which acts at the same time, suppose you are holding a hand and you people are running a circular path. So suddenly if your hand get detached from the other person, so you will fall out from the circular motion. Same is the case of a string. When you have tied a stone with a string and that string is connected with the stone, and if the string breaks then the stone goes straight. So the force which moves the object outside the circle, which force was then waiting to move the object outside, that was the centrifugal force, which is outside, which tends to move the object at the same time. If the action is centripetal force, then at the same time reaction is also acting on the force. That reactional force is basically centrifugal force, which tends to move the body, which loves to move the body outside the circle. So what are the examples of first of all, we are going to complete centripetal force. Centripetal force, the center loving force. You are having a shot put or any other type of uh, sports action or sports play. During the time when you are in athletics competition, you use to throw such types of the object, and these objects are tied with your hand, and you are applying basically centripetal force to keep it in the circular path when you're revolving in the circle. When you're trying to move in a circular path, a stone tied to one end of a string, rotating in circle, moon revolving around the earth. These are the examples of centripetal force. Earth is applying a force on the moon. This force tends to move the earth around the sun. This force tends to move the moon around the earth. That is called centripetal force. What's mathematical form? If an object of mass m is moving with velocity v, suppose you are holding you have tied a stone. That mass of that stone is m, and it is moving with velocity v. So what will be the distance or the length of that string is basically radius of that circle, and it is equal to fc is equal to mv square divided by r. This is the formula which is used to calculate centripetal force. If you look at on what the factor this centripetal force is depending, number one, velocity of the object or the stone through which it is moving. More is the velocity, more will be the centripetal force. More centripetal force is required to hold in the circle. If the mass is more, then you need more centripetal force to keep the object in the circular path. But in case if the radius of the circle increases, it becomes very difficult. Then the centripetal force decreases. Its strength decreases with the increase of the radius distance from the point of rotation. So here it is. This one is centripetal acceleration. And if you move back, I have, along with centripetal force, I have also discussed about the centrifugal force, the force which tends to move the object outside the circle. Both have the same formulas. If one is action, other one is reaction. Simple is that. One is center loving force, other one tends to move. If the action is centripetal force, then the centrifugal force is its reaction, which will always wait and tends to move the object outside the circle. And there are so many distractions in the world. You people have so many times observed or seen in the movies and other places where an object leave during any type of circular motion, it moves away. So this is the concept of centripetal acceleration. The centripetal acceleration produced by a centripetal force which is always directed towards the center of the circle is known as centripetal acceleration. It is represented by AC according to Newton's second law of motion. F, if a force acts on a body of mass m, if it produces the acceleration in the body, then this is the formula used to calculate force, and it is also used to calculate acceleration of a body of mass m. So here acceleration is centripetal acceleration, then this acceleration is equal to MAC, and at the same time when this force acts, what it does, it moves the object inside a circular path. So that's why mv square divided by r. What was happening? You are holding any type of stone which you have tied with the help of a string, and other end of that string is in your hand. When you are trying to move this stone inside circle, each and every point the direction is changing. With the change of the direction, velocity is acceleration is produced, and that type of the acceleration is produced in a string. So this is the formula used to calculate uh, acceleration of a acceleration produced in a body of mass m. At the same time, look at the back side and look the pattern of that type of motion, where the object is moving. That object is moving inside a circular path. So it means this type of motion, Newton's second law motion, which the force producing acceleration in the body of mass m is basically due to centripetal force, and this centripetal force formula is this one. If you simplify it, m cancel with this m1, then it will be AC is equal to V square divided by R. This is most important formula to calculate centripetal acceleration, and it depends on velocity of moving object inside a circular path as well as the radius of that circular path. So dependence on what the factor they depend. Equation shows that the centripetal force of the body in circular path depends. I have already discussed on what the factor centripetal force depends. Mass of the object. More is the mass, more you need, stronger force you need to move the object inside a circular path. More is the velocity of the object, more will be the centripetal force required to keep it in a circular path. But more is the radius, less will be the centripetal force. It is inversely proportional. And what about the centrifugal force? And what the factor? It depends. It depends on the force which compels the body to move away from the circle. This is the concept I have already discussed. The reaction force of centripetal force, then it exists as long as a centripetal force, because if one is action, other one will be reaction. Whenever you are applying some types of centripetal force, at the same time, basically it is producing, if it is action, there will be a reaction. And that reaction is basically, this reaction will be due to centripetal force. And this centripetal force is basically producing some reaction, and that reaction goes, reaction of that centripetal is centrifugal force, and this is the centrifugal force. It exists as long as the body moves along a circular path. Our body is having centripetal force. So these are some of the examples which you have already seen. Look, the motorcyclists are moving inside a circular path, and similar is the case in case of a park where there are number of playing areas, number of toys, number of swings, a number of other types of the activities in the park, where in our daily life, thousands of physics applications are there. And it becomes more easier if we look at these types of the motion. It will be more easier for us to understand what type of the motion is, either it is centripetal or it is centrifugal force. At the same time, if then these motorcyclists lose their centripetal force, of course, they will move outside. And sometimes people have seen, and it becomes very much dangerous. Sometimes it's too much dangerous for the construction buildings and other types of scientific constructions. Now, here is the example of centrifugal force. Stone is tied to the one end of a string and willed. The body exerts force on the hand to move away from the circle. It is called centrifugal force. And when it comes in action, whenever you see that it spring breaks, it moves straight. Which force is keeping it to move away? Which due to which force it is moving away from the circular path? That is basically centrifugal force. And what are the applications of centripetal force? Banking of road. We used to have the outer edge of a road higher than the inner side, so that this outer edge during a hilly area, this outer edge is providing centripetal force for the car so that it's not moving outside the road. Centrifuge is another example where centripetal force is applied. Washing machine dryer. Look at whenever there are particles, water particles inside with the cloth, they are attached with the cloth, and centripetal force acts. As soon as we increase the speed, and you people have seen that with the increase of the speed, you need to keep more force is required to keep the water molecules attached with the cloth or any other types of the object. But as soon as we keep on increasing the speed, then the centripetal force decreases and centrifugal force increases, which results in the detachment of water molecules from the cloth or any other types of the object. And by this way it works. So cream separator is another type of the example where huge light and heavy particles separated and centripetal force is decreased, centrifugal force is increased, and they are separated from the circular motion. So these are some of interesting applications from our daily life to understand what type of the motion is centripetal force and what type of the motion force is the centrifugal force. But interesting thing is that both are acting at the same time. I thank you very much for your patience. We hope you people have understood this topic. And till for the next class, thank you very much. Have a nice day.